This video is going to talk about how to solve rational equations. So something we need to review is how you solve a fraction equal to a fraction in this first example. So when I have a fraction 2/5 equal to 4 over n, in order to solve this without guessing and checking, I would cross multiply. So I would have 2n equals 20, so then n would equal 10. Now, this was a simple example, but we're going to be using this type of solving to solve more complex examples. For example, in number 1, I have x over x plus 2 is equal to 1 over x. So I'm going to solve this by finding the cross product, or by cross multiplying. So I'm going to do 1 times x plus 2 and x times x. So 1 times x plus 2 is just x plus 2. X times x is going to be x squared. Now I'm going to move over the x and the 2 so that way I can have a quadratic equation that I can solve. So when I factor this, I'll get x minus 2x plus 1. So my solutions are 2 and -1. Now, I need to be sure that both of these answers will work. So I need to think back to the beginning of this unit when we talked about excluded values. So my excluded values are anything that makes my denominator equal to 0. So in this case, my excluded values would be, well, let's look back at my original equation. The denominator was x plus 2 and x. So my excluded values would be -2 and 0. Since neither of my solutions are my excluded values, both of my solutions will work for this problem. Go ahead and try example 2. Pause the video, try it, play the video, and check your answer. All right, let's look at number 2. So first I cross multiplied, so I got a times a plus 1 equals a plus 1 times a minus 4. When I multiplied that out, I got a squared plus a equals a squared minus 3a minus 4. I moved everything to one side, and I got 0 equals -4a minus 4. So actually my a squared subtracted, so I'm left with the linear equation. And when I solve that linear equation, I get a equals -1. But then remember, I have to think about my excluded values. So my excluded values were 0 and 4. Since -1 is not one of my excluded values, that means this solution works. So cross multiplying is one way to solve. This only works if I have a fraction equal to a fraction. If we look at example 3, now I have an addition equal to something else. So the way I'm going to solve this is by finding the LCM, or the least common multiple, or in this case, we're also going to call it the LCD, or the least common denominator. So remember, my 3 is technically over 1. So my goal is for my equation to get the same denominator all the way across. So as I can see, my denominator on the left side is a plus 1, so I'm going to apply that denominator on the right side. So then my equation will be a over a plus 1 plus 3a plus 4 over a plus 1 equals 3a plus 3 over a plus 1. So one of the cool things about rational equations is once my denominator is the same, I'm only going to focus on solving the numerator. So my equation is going to be a plus 3a plus 4 equals 3a plus 3. Because when you have fractions, once the denominator is the same, the only thing I have to worry about is the numerator. So now I'm going to solve. 4a plus 4 equals 3a plus 3. Well, a is going to equal -1. But now, remember, you always have to think about your excluded values. So, excluded values. My excluded values in this case would be -1. Uh-oh, my solution was -1. That means that this is actually not a solution. So, this equation, in fact, has no solution. So, if I had a second solution that did work, then my equation would still have a solution. But since my one and only solution was an excluded value, that's why I have no solution. All right, let's try another example like this, but maybe a little bit tougher. So if I look at example 4, all of my denominators are different. So I'm going to first start off by factoring this first denominator, and I can tell that it's a difference of squares, so it's going to factor into a plus 5, a minus 5. So my goal when solving is I want to get the same denominator all the way across. So if my denominator of my first fraction is a plus 5, a minus 5, then to get that same denominator all the way across, I'm going to multiply this guy by a minus 5 over a minus 5, and my last fraction by a plus 5 over a plus 5. Because then I will have 2a squared over a plus 5, a minus 5, minus a squared minus 5a, a plus 5, a minus 5, equals 7a plus 35, all over a minus 5, a plus 5. Well, now that my denominator is all the same, I can focus on just solving my numerator. So I'm going to have 2a squared. Be careful here. I'm subtracting both of these numbers. So it's going to be minus a squared plus 5a equals 7a plus 35. So I'm going to have a squared plus 5a equals 7a plus 35. I'm going to move everything to one side. So I'll have a trinomial of a squared minus 2a minus 35 equals 0. Well, this will factor into a plus 5, a minus 7. So my two solutions would be negative 5 and 7. But don't forget to think about the excluded values. So I'm going to go back up to the top, and I'm going to put them right next to this 4 here. So a cannot equal 5 or negative 5, because those are the two values that would make any of my denominators 0. So the only true solution is going to be that a is equal to 7. All right, let's skip ahead to number 7. Now in number 7, all of my denominators are different. So there's a couple ways we could approach this problem. I could get a common denominator all the way across and then only solve the numerator. But that's going to be a lot of multiplying, because then my common denominator is going to be n plus 1, n plus 8. So instead what I'm going to do is I'm going to get a common denominator on just the right side of the equation. And I'm going to do this by multiplying the top and bottom by just n plus 1. And the reason I'm going to do this is because then on the right side, I'll have a common denominator. So I'll have n plus 7 over n plus 1. And then I can set that equal to the left side, which was n plus 5 over n plus 8. Now, kind of like we did at the beginning, I have a fraction equal to a fraction, so I can cross multiply. So I'm going to have n plus 5 times n plus 1 equal to n plus 8 times n plus 7. So n squared plus 6n plus 5 equals n squared plus 15n plus 56. Now I can see my n squareds are going to subtract. So I'm going to have 6n plus 5 equal to 15n plus 56. So now I just have a linear equation that I need to solve. So I'm going to move my n to one side and my constant to the other side. And I'm going to end up with a fractional answer, but that's okay. So n is going to equal negative 51 over 9, but actually that simplifies, so it's going to be negative 17 over 3. So let's double check that negative 17 over 3 will actually work as a solution. So remember, you need to think about your excluded values. So my excluded values are n cannot equal negative 8 or negative 1, because that would make my denominator 0. Since my solution is neither of my excluded values, then my solution is viable. Let's scroll down to number 9. Now in number 9, you're going to have to do some factoring and get a common denominator all the way across and then solve. Pause the video now, give number 9 a try, play the video when you are ready to check your answer. So in solving example 9, my two denominators that are trinomials factor into x minus 6, x minus 3. So to get the common denominator for the middle fraction, I multiply the top and the bottom by x minus 3. So that gave me an equation of 5x minus 20 plus x minus 3 equals x minus 4. Because once all my denominators are the same, I can just focus on solving the numerator. So when I solve that, I got an answer of 19 over 5. Now, keep in mind, what are my excluded values? X cannot equal 6, and x cannot equal 3. So since neither of my excluded values are one of my solutions, 19 over 5 works. Go ahead and try example 10. You could solve this a multitude of ways. You could solve this how we did number 8, where we got a common denominator on one side and then cross-multiplied. Or you could solve it like we did in 9, where you get a common denominator all the way across. Either way, you should get the same answer. So go ahead and solve, and then let me know, and then pause or play the video when you're ready to check your answer. So in number 10, I took the approach of getting a common denominator on the right side, which was n plus 1, n minus 4. Once I got the common denominator, I combined the numerators, and I got n squared plus 2n minus 5 all over n squared plus 3n minus 4. Then I cross-multiplied. Remember, I can write 1 as 1 over 1. So when I cross-multiply, I'm really just multiplying the top and the bottom by 1, which means I really am just setting the numerator equal to the denominator. Then I could solve, and I got that n was equal to negative 1. But then remember to check for your excluded values. My excluded values in this case would have been negative 4 and 1, as I wrote up here at the top. So since my solution was negative 1, this solution works and is not an excluded value.